Good afternoon, everyone. Oh, I will not stand here. Good afternoon, everyone. Very welcome at the presentation from Borit. So for the people that don't know Borit yet, we are a producer of metal bipolar plates, mainly used in fuel cells electrolyzers. And I'm here today to talk a little bit on the scale-up, so the status where we are today and how we see, let's say, the next few years evolving in the production of bipolar plates. Here is an overview of a bit the history and a little bit on the future. There's more to come. So the company started in 2010 with the technology based on hydroforming, so Hydrogate, direct hydroforming from coil. At first we had a press, and then later on we invested in other technologies like laser cutting, laser welding. In the years, let's say 2012, 2015, we have been very successful in acquiring different customer projects, doing projects for various applications and various customers, but still in the prototype phase, so small amount of plates. At a certain moment, we have been challenged to scale up to a bit bigger projects, so tens of thousands of plates. And of course, at that moment, the cost efficiency becomes very critical. So we invested in better, faster machines, more automation in order to then get the costs down. And currently we are, let's say, then in a phase where we are discussing with the next step of the development, which is then localization. That means producing parts much closer to the customer. This is an overview of the facility we have in Belgium, in Geel. It's about 30 kilometers from Antwerp. Production space is 3,500 square meters. I think what is most important is that the output is roughly 500,000 plates. So this year we'll produce more than 400,000 plates, and we have the capacity to do even a little bit more. Just as a side track, you see the windmills and the solar panels on the roof, so we are, let's say, eco-conscious, to say it like that. Main markets where we are in, as most people will know, it's not only motive, to say it like that, but also SOFC applications, for example, stationary, where we do a few nice projects. We are supplier of one of the, or a few of the bigger electrolyzer companies, but the high volumes, especially in number of parts or in number of plates to be produced, is of course in transport. We do, let's say, various applications, aviation, marine, and so on, but the main volume is in logistics, forklift trucks, US then, of course. And yeah, you see the cars driving outside. That's of course where the real volume is. Just as a side remark, from our customers, we have the feedback that especially in the materials handling, even today there is a positive ROI for an investment in fuel cells. So if you have a huge warehouse from Coca-Cola or Walmart or so, with 500 forklift trucks, it makes sense today even to go to fuel cells and have a positive ROI on that investment. Most important, I want to show you a little bit on the technology that we are using to produce these parts. So there are two key process steps, which is the forming and then the welding of the parts. For the forming, we have this proprietary technology, which is called Hydrogate, so forming directly from coil. The process is rather simple. You have a tool that is the negative of the part you want to make, and then the water pressure, 2,000 bars, pushes the coil from the material into this tool. The speed at which we can do this or the press at which we can do this has a takt time of 8 seconds. So that means it is for sure for the first few years, speed is fast enough. We can do on one press then 2-3 million parts, depending a bit on how long, how many shifts and so we run. What is also important is we do one-step forming, so that means the tooling investment is really minimal. It's a one negative tool essentially. You don't need a male and a female or different steps. Which also means, of course, that the investment in the tooling and the turnaround time of a project is then very fast. What we also have the possibility is to use multi-cavity tools, meaning we can have typically anode and cathode for a bipolar plate, or if you have smaller parts, we can even have 4, 6, 8 of one product in one tool, which again reduces, of course, the cycle time or the virtual cycle time, and the output goes up. Key aspects why this is different than mechanical stamping also is that the process is rather gentle. So it's not a very aggressive stamping process where you hit two tools together essentially. You use the water to blow up or to move the steel or the material. And it means it's a much more gentle process, very compatible with pre-coated materials. So we have the experience that the pre-coating works very well in this process. Also, because it's a gentle process, we have an advantage when the material is thinner. So typically for stamping, the material, when it becomes thinner, it becomes more difficult. In our case, it becomes even easier, to say it like that. When the grades of the material when the thickness goes down to 50 microns, for example, we do a few projects. Typically, it's 100 to 75. What we also see is that because the forming pressure is the same everywhere, we have a very high dimensional accuracy, meaning low tolerances on these plates. As a second process step where we really feel that there is, let's say, added value in our company is this laser welding of these plates. And the welding of two very thin metal sheets together is not so trivial. The key concept there is you want to go as fast as possible to have the limited amount of heat injected in your plate. You don't want to go very slow and then have a lot of thermal stress in the parts. So that means we go as fast as we can, up to 1 meter per second welding speed. The way to do that is then to go with a scanner system or a remote welding system. Of course, we also need some tooling there to clamp the two plates together and to fixture the plates. And we then also have the shielding gas flushing over the plate in order to avoid the oxidation. And then here on the roadmap, we see, let's say, 3 stages in the scale-up typically. So we start, of course, with the design for manufacturability, and that's clear. We first want to give the customer feedback on okay, can we make the design? How will it look like? What are the cost drivers in there? Once we go through there, we have the design freeze ready, and everybody agrees on what we will be making. And then we start with the prototype manufacturing, the tens of plates, hundreds, a few thousand perhaps of plates. That's where the tooling is validated. That's where we do the setup of all the processes, a first quality check, first article inspection, and so on, to make sure that the plates are okay. Then when, let's say, and the product and the process is mature enough, we go to the next step, which is what we call pre-series. That's essentially where we are today. So in the order of magnitude of a few thousand up to a few 100,000 parts. Again, main focus is getting the product stable, getting the process stable, having constant quality coming out, and just make sure that everything is working perfectly. The next step, and let's say this is the phase where we're in today, the next step will be indeed to go to much higher volumes, to go, of course, to a much lower cost, because cost is critical, but we feel that this will not be able to do that on a, let's say, general purpose equipment and a general purpose setup. Then you really need a dedicated setup for bipolar plates with a certain footprint and so on, with dedicated machines. And then you can scale up to 100,000, 500,000, a million parts and achieve the cost targets. So that's more or less my presentation. I think, any questions or?
Thank you very much, Dr. Gert Nelissen. Are there any questions from the audience? No? Okay.
It was too clear.
What?
It was too clear.
Too clear. Okay, then let me have the first one maybe. You talked about also the electrolyzer, the PEM electrolyzer, and everybody this week, or many are talking about the large-scale electrolyzer.
Yeah.
Could you maybe elaborate a little bit more about how is this affecting you with your plates?
Well, the thing is, of course, that we don't do the product design of any of these plates. So we are essentially depending on what the customer is designing. But also there on the electrolyzers, we see a clear growth that the project become much more, let's say, industrialized and much closer to real volume production. And people having a roadmap where tens of thousands, hundreds of thousands of plates are required. So.
Thank you very much. Further questions from the back?
Thank you. I think that you get at least one question from the audience. You're looking forward to that, right?
Yes, of course.
Anyway, you were just mentioning that you are manufacturing 400,000 plates this year.
Yes.
What would be a good guesstimate for the next 2 or 3 years? Will it be ramped up to 30%, 50%, 100%?
A factor of 10.
A factor of 10 would be 4 million.
Yeah.
Okay, so that would be within 2 years?
2021, 22, yes.
Okay, from where do you see this growth? From the automotive industry? I think that I'm not the only one asking that question.
No, but if you look here, it's rather easy to explain. So the amount of plates needed for a typical stack in SOFC are 50. Amount of plates needed here are a few hundred, but of course they have a limited amount of systems they produce. Here you have, of course, and the big stacks, so a lot of plates, and the big volume. So it's clear that in this area, the transport area is where the big volumes will be. So we have 2 or 3 customers, significant customers, reliable customers that ask us, what is your plan to produce 1, 2, 3 million plates 2021, 22?
You're talking about automotive OEMs, I would assume.
An automotive OEM, an truck OEM, a whatever, yes, those kind of customers.
Who makes the decision what kind of material you will use for the bipolar stacks?
Always the customer.
Not yourselves?
No.
Well,
we build to print.
I'd like to dwell into further details maybe after your talk. Thank you anyway.
Thank you.
Thank you very much. Further questions from the audience? Okay. Thank you for your explanations.
Thank you.
If you want to discuss the topic any further, please go to their booth. It's booth E67E1 in this direction.
Yeah, over there.
Sorry, in this direction. Thank you again.
Thank you.